Uh, the title of this talk was Urban Systems Engineers Wanted. So the title is there to let all of us know that we need system engineers look across the entire system as opposed to just looking vertical. We need both vertical and horizontal. So we are relatively good actually looking at verticals, but we have not invested enough in looking at the horizontal. So within national development, I'm pushing very hard for, I'm an advisor of national development as well, that they should build up this capability of urban system engineering. So a point you made earlier is that how will we face the problems in the future? We are no more a developing country where we can follow others. So in the past, before we do anything, say, now, who has done all this? Then say, we look for the best of the class, just follow. But in many areas, we are way ahead of that. No one to follow. In which case, then you must have enough self-confidence that, I'm the leader in the world. But there are lots of options, lots of ways to go. Which particular route to take? So now you put money into research and development to chase different options. So to refine ideas, say, I think this is the right path. Because we are very invested in our research and development to go that direction. That's number one. Number two is that you must be able to integrate the different technologies that you're doing in development into a larger system. So hence the need to have both the R&D and the system engineering. So the insertion of technology is actually an art. So you have got to do the research part and then creation of technology. Though quite a lot of things are out there, but our problems are unique. And in many cases, we are ahead of the curve. So I give an example of the underground ammunition facility, which I did not elaborate. We developed a code that later on became the code for the US Department of Defense and NATO. Why do we want to do that? Because if we did not do that, we use a standard code, we need 240 hectares of land. But by developing a code, but what does that mean? We got to do the research, computer simulation. Then after that, how we know simulation works? Validate the model. So we do small-scale testing. But how we know we can scale up? So I need to have a tunnel that's big enough to blow up 10 tons of explosive. Where? Look, for 2 years, Singapore gave up. So we finally decided on Sweden. So we built a tunnel complex in Sweden that we can do the testing. So after testing, we got results. We can write our code. And then all experts from the NATO and US, they participate in our test. They took our results and said, sounds very sensible. Now they change the codes according to what we have done. So I give examples that the methodology is there. You have an idea. The idea must be backed by science. That means you go do research. Then you say, the methodology is find element modeling, FEM models, but how you know the models actually work? So you need to validate. So a major part is testing. And for urban systems, you require the most complex parts. Will the people actually accept it? So that's why the HDB doing it, do it at precinct levels, try small things, and then bring people in to use it. So the methodology has been there, but now you don't have the luxury of time that take 10 years. You have to compress it. So you must have a means to make decisions very quickly. Find a way to do things in parallel. So one made decision can move very quickly rather than, right now we do things linearly, step by step. So the time is a very valuable thing. We can't wait. We are ahead of the curve. Enjoy being ahead. Create something new. And then other cities say, you've done it, we want to follow you. That will create economy for benefit for ourselves, for companies to go around the world selling our solutions because we have done it in Singapore, we show it works. So we got no choice. We already passed the stage, we can just follow others to reach a stage that we have to create a future for ourselves.